Alright, hey everyone. This is making a Pokemon save editor in C. I don't know how many of these I've done previously. Maybe this is the 16th one. So we had a very successful previous session, so we were actually able to modify the protected data. So basically the game takes steps to actively try and stop you messing with Pokemon data. So this is where things like what moves your Pokemon has, how many EVs it has in a particular stat, how much XP it has. This is all effectively encrypted data. So we were finally able to decrypt that data, modify it, re-encrypt it, write it back, and we gave our starter Squirtle the move Surf. I also, in the previous episode, checked this into Git, so there's now an actual Git repo here, so I can go over some changes that I made a couple of days ago on my lunch break. So the first one is adding in the step that I missed last time, which was I had one attempt at modifying Squirtle's data, and it didn't work, and the reason why was because we didn't write Squirtle's checksum back. Like I said, we calculated it, but we didn't actually set it back before resaving the save data. I did a couple more minor changes here. So in moves, this enum here, I've prefixed everything with move. So very minor, mostly cosmetic change. I don't know what I did there. What did I do? Oh, compared with my clipboard for some reason. So then main change to reflect that. Pokemon.c. Yeah, so also in the Pokemon kind of data order enum that reflects this here, I prefixed the variations with PKMN data order, so that helps to keep it a little bit more tidy. Then what did I do here? So I've added all of the cases in, so dealt with this to do, and I've added all of the cases in here. And I've verified that we don't actually need this init 12-byte section code anymore. I don't think I've removed it yet. I've just put a to-do that's like, I think we can remove this, but straight up calling memcopy is fine. So I'm going to leave that. There is actually another to-do here, which is what should we do if nothing matches? But we can only call this function using get substructure order. So, well, actually, sorry, this function calls get substructure order, which can only ever return a value between 0 and 23. So we're never going to have an instance, realistically, where we pass to this function and it does nothing. Or, sorry, where we pass something to this structure and the switch doesn't match any of these cases. So I actually think we don't need this, like, memset in case of emergency. Just fix a random byte. I don't think we need that, so I'm actually going to remove that right now. There was also another change that I did, something at the top of the file. Oh no, that's the to-do. Okay, I guess I removed that line. Or was it Pokemon.h? Okay, I added one line break, you can see on the right-hand side, and I adjusted some of the spacing. So, like I said, very minor cosmetic things that I've done off screen. Very straightforward things to do. So this time I actually realized that there was a problem. that needs debugging first before we can actually continue with anything else. So if I go to the GBA folder, which contains the ROM and the save file, this is my modified one, so I'm pretty sure this is hacked, but this is our known good copy. I really should clean up basically all of these, but this is our known original good copy. So if I copy this file back, so sav copy 3 to pkmnfr.sav, which is the file that is read in our program, somewhere near the top, yeah, pkmnfr. Also, maybe I should make this text a little bit bigger. Oh yeah, that needs to be bigger than 12. Let's make it 14 so you can see it a bit better. Yeah, so we're starting from scratch here. This is our original file. Now, if I was to run the program... Oh, I've messed something up. What did I do there? Case default break. Yeah. What's the issue? What? Okay, we have a bunch of warnings. We have one error. Expected expression case default. Do we not need it then? I assume we do. It's just complaining. Or do we actually need to do something we can't just break? Is that what it's gonna do? No. Okay. What have I messed up here then? Case default. What did I change? Literally removed one line. Now it won't compile. Or is it from this one? Because there's 2 enums in this file. Okay, this is where I removed... Okay, so I did a printf in the wrong block. Alright, fine. But it's... Is it this one that's complaining about? 182... Yeah, 182... Oh, and then it complains again about 357. I don't know. Let's just Google that one. Okay, C, case default, expected expression. You have to enclose this in brackets? Oh, we don't say case default? What? We really don't? Okay. Sure. This is what this random website is saying. I've not had the most luck in the past with Geeks for Geeks, so we'll see if this actually works. Okay, it does. Yeah, so if I set my squirrel's name to, like, I don't know, hello, in our main program, so, like, as one test, we changed the nickname because that is unencrypted data. So it's in this section here, nickname, and there's no encryption on this, but there is encryption down here. So we can change the nickname, that's fine. And then we run a whole bunch of code that decrypts Squirtle's data and assigns it the move surf with 15 pp, calculates its checksum, writes it back. Now the issue I'm running into is for the successful result that we had last time, I can't reproduce it for some reason. Let me put the VBA over here and do... How do we scale this up? Scaled resize 4 times? Yeah. So, you know, if we skip through all of this and actually load into the game, if I press start and go to Pokemon... Oh, hang on. I haven't... I write to a different file called dump.sav, so I'm gonna copy dump and replace Pokemon FR SAV with that. Okay, so this is using our hacked file now. So if I reload this ROM and we go through again, Now when I go to Pokemon, we don't see anything at all, which is really weird. But I can press A, and it does seem to recognize that we have Surf. Does it recognize we have... Okay, we have a hacked item. And when I go to summary, it just completely crashes. So, what's weird is that if I was to run this exact code again and do the exact same thing, and then move the dumped file into our main one and just rerun. So let's go back. It actually works this time completely fine. So why doesn't it work with a clean file? I also wonder what it's going to do a third time. If I was to try it one more time, because we've now... So this is now a hacked one that's good. So if I was to do it again, I wonder if it's going to break. Like maybe it's some kind of toggle. So I'm just going to put high instead this time to prove that it's changed. So let's move the file and reload. So now that we're back in the game, what happens this time? Okay, now it breaks. So when we try and modify a supposedly hacked copy, it doesn't work. Oh, sorry, it does work, and then when we modify a clean copy, it doesn't. So something is going on with the clean copy that clearly doesn't match with what we're trying to do. So if I put the clean copy back, what I'm tempted to do is debug up to this breakpoint and actually just check that our... Oh, actually, we want to... I mean, I wonder if the clue actually is in the printing. So the original checksum and the new... Oh, why is the new checksum in this case different? Sorry, why are they the same? They shouldn't be the same. Oh wait, no, actually, sorry. They should be the same because the Pokemon checksum is for its protected data, which we haven't changed. But we did change the nickname. Okay, so I wonder if the checksum calculate is still wrong. Sorry, it's not save checksum calculate. It's... I'm going to turn on the structure here. Calculate checksum might still be wrong. Not that I know what would cause that. So actually, I guess this printing is useful for the moment. Unless I... Can I write it to standard error? How does fprintf work? Fprintf is... Okay, so first argument is the file that we want to write to. Okay. So I guess... I think we can just do stdr. Okay, and then if nothing else, it will keep this separate from everything else. So if we did that again, yeah, okay. Okay, so when we take the original file, Squirtle's checksum is 8A54, and that's right. Because that's what we were seeing last time. And also, 998D, I think, is correct when we calculate the new one as well. So this is calculate checksum against decrypted. Just to verify that we don't have an error here, I'm going to run the calculation against the data before we modify it. So after we've decrypted it, but before we've made changes. So that's Squirtle's original checksum. If we go here, let's say... let's actually just call this calc. So instead of Squirtle checksum, this needs to become original Pokemon checksum. And we're not running this against decrypted. We are running this against... oh wait, no, sorry, we are running this against decrypted because we've not modified it by that point. So I don't know. Let's try running that again. This is going to run against the original because we haven't moved the dump.sav back. So let's put in some characters and see what we get. Okay, so the calculated one is correct. And we definitely write to dump.sav. So if I was to copy this file back and try running again, it should fail. If because I haven't changed anything. So it should, yeah, it should crash. Okay, that's fine. Well, it's not fine, but at least it's not being completely unreliable, which is good. So, what is the matter here? Why is it doing that? So let's verify we're doing everything in the right order. So we decrypt the data for Squirtle, which we know is right because we have the same checksum calculated on the decrypted data before we change anything versus what we've read from the save file. So that's fine. Okay, so we make the modifications. Then we calculate the checksum again and write that back. Then we re-encrypt the data, calculate the checksum for the save block, or sorry, the section. This should really be save section checksum calculate, but sure. And then we set this the section one back as well. So the only thing is, this definitely isn't the case, but where is team item section coming from? Save get section by ID, and that gives us a specific section from the save data itself. So, okay, that's not the issue. Why? Why then is it fucking up? I would be interested to hit the break point. Okay. Yeah, I would be interested to hit the break point and see what's happened here. So at this point, we have a whole bunch of like variables in scope. Now, what I want to see is what have we written back to Squirtle's data by the end. I mean, it looks relatively sensible. So I can't see why 998D, that's the checksum value, and that matches. So I'm not convinced that is the issue. Let's go to this text file that we've been using before. And this makes reference to something called ABCD structure, which is here. So in the actual bytes of a Pokemon's data between 32 and byte 32 and byte 39, you have the data. But what I'm interested in is all of this before it any good? So the byte before that, bizarrely, is saying it's the checksum, but it's actually, I don't think it's byte 30 through 31. I think it's 28 through 29. So actually, maybe the Bulbapedia page is more reliable in this case, because this seems to reflect better what we're looking at. Whoops, sorry, we're not looking at the actual data at this point. So if we compare our memory view to what we're expecting to see, so we have, so data starts at the green. So then we have a 16-bit integer, or 2 bytes of, we don't know what they are. Then our checksum. Then markings, which is an 8-bit, so 1 byte. Then our OT name, so this is like ABCBA, or whatever we called our trainer. Then some kind of miscellaneous flags, which is stored in an 8-bit. Okay, what is going on there? Is language supposed to be just Fs? And also, is it 7 bytes? I don't think so. Let's actually try and look at this through here. So OT name is this. MISC flags is that 1 byte there. Language is 255. Is that right? Okay. Wait. Pokemon is treated as a bad egg. Have I fucked something up here? Hang on. What I haven't done is actually tried before running the program here. Because actually I may have just completely messed up copy 3. Because bit 0 must be set, because this is 2. This is the literal number 2, so that means bit 0 and... Oh wait, no, actually, no, that would just be bit 1, wouldn't it? Because it would be an odd number if that was set. Let me just verify this real quick. Okay. No, so yeah, PKMN FR copy 3 is fine. Sorry. Okay, that's fine. So the only flag we have set here is has species, which is always set, basically. Okay, cool. So then prior to that, we have nickname. And this is what we... That seem... Is that 10 bytes? Yeah? Okay. And what did I set it to? Help? Or something like that? I think it does say. Yeah, HELP. And it outputted those bytes, and then the rest were filled with FF, which I'm going to assume is okay. Hang on a minute here. What happens between... Okay, so the only question marks we have at the moment is why is language set to 255? And suspiciously, it's an FF bit. So... Right now, language is what I think is wrong. So what I'm going to do is make sure that copy 3 is what we're working on. And then I'm going to run the program once, and this should be bad, okay? So I'm going to do a nickname hi. And then move or copy dump.sav, which is the output file, back to our original. So this should be broken. So let's see. Okay, it is. What I'm tempted to do is actually open our file in a hex editor and change that specific byte, although it's going to be a complete pain in the ass to find it. In fact, maybe I don't want to print the offset of Squirtle. Or are we doing it in here? So I have a so basically if I load this not GBA, SAV. If I load this SAV file, I need to know where to jump to if I was to change that 1 byte. In fact, let me just do that in code. That's going to be way easier. So, what we want to do after this is set... what's strange, though, is... Oh no, checksum doesn't necessarily verify if your data's bad. Okay, all right, fine. So Squirtle language should be 2. Because what I think we've done is in the set nickname function, we've written too much. We've written too many bytes back to the Pokemon. So let's make sure that we're dealing with our original known bad file. And then let's try that again. So that's now saved back to dump. Then we want to put dump back in Pokemon. So was that our problem? It was not necessarily our problem. Okay. Dang. Okay. What do I want to do here? Somewhere I have a function for... It might be in my main, which I should probably move into a utility. Yeah, print section address relative to... Oh, so we should actually be printing the team items section somewhere. 5,000. Okay, so this is where I need to jump to in the hex editor, which I'm going to put on the right-hand side of the screen. So fr.sav, and we want to go to... Where's our jump to? Am I blind? Oh, they've moved it. Okay. Or have I moved it? Or did they move it? I swear it was on the left-hand side before. So let's jump to 5,000. So immediately this is... what is this? What is this? What is this? What is this? So in team items, so we have some kind of byte. So 4 bytes for team size, and then straight away we start with the Pokemon. So, is it 4 bytes? Yes. Oh, but that starts at offset 3.4. Okay, so actually I want to go to 5003.8. So this is Squirtle's data, yep, and we know it is because 8FCF74 is our decryption key. So this is like a blank section, or it just has not much data in it. What I wanted to look for is... So 5003.8 is the start of the block. So I'm guessing this is the nickname. So if we look at a Pokemon data structure, I might need the programmer calculator for this one. So 5003.8 is where we start. So that's this byte right here. And I want to jump to language. So it's 5003.8 plus 12, which is 504A. Okay, we did set that successfully to 2. So I don't think that's our problem either. And then is this 10 bytes? I think it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. It only crashes when we look at our Pokemon list. So it could be when it's trying to print the name. I do wonder if we can... If there's like a diff tool, that would be sick. But I think we're just gonna have to do 2 different kinds. Okay, so we know that if we were to run this program again, it's gonna work. But this is our original... I don't know if we can rename the tab that we have open, because I kind of don't want to write it back. So what is this music? It's like playing an organ. Okay, let's do cp Pokemon fr.sav. Let's just call this bad for the moment. And then let's close this and open bad and jump to that same address. And then let's get the good one, which we get from just running our program once again. And let's sense check this by doing the same nickname. Hopefully it doesn't matter that I didn't quit VBA. Hopefully that's fine. So now it should be fine. Yes. And it's also set our nickname properly as well. Okay. So what I want to do now is cp PokemonFR.sav to good.sav. And then let's open that in the hex editor and go to the same address. And now we have the very exciting job of figuring out what has changed. Although what we probably should do is go to the start address, which is 5038, and see what's different between each one. 5038. So 5F4FE1, 8D, D0. I mean, probably what I could do here is copy these bytes. Okay, that's a code snippet, but that's not what I am necessarily looking for. How are we gonna... okay, let's do a code snippet. Does it do Python? Yeah, it does. Okay. No, don't do that. Let's do... Let's go to our folder, and let's do something like bytes compare. So let's paste in what we have there, and this is good. We may even be able to see like what the specific problem is if we go to bad and we go there and we select that same number of bytes and export as a Python code snippet. Whoops. I need to copy and close and then paste. Yep. So for I in rangeland bad, if bad I is not the same as good I, let's do then let's print the byte for good I as hex. I assume that's valid once we indent that block. Yeah. So then let's do Python bytes compare. Python 3 bytes compare. Okay. Oh, 32 all the way to 77. Byte 32? Interesting. Okay, what is... Oh, hang on, sorry. It's the 32nd byte in here, so 20. So 5038 plus 20 is where the issue starts happening, so... Oh, at the start of the data. So the data's not right? I mean, I think this is the start of the data because I'm seeing 888CF. Oh yeah, hang on. This is 8FCF 7408. Oh, this is very different. Okay, everything matches up till then. Okay, so it has to be an issue with the data. Damn, okay. I need to then see... I'm going to need to see the decrypted versions of each to tell what's going on here, because this has been encrypted again, so I don't know what any of this is. Dang, okay, fine. So here... I guess we can comment this out if I can remember how to do that in Vim. Replace every start of line with a hash. Yeah? Cool. So we need to copy those same byte arrays pretty much. Fine. So what I need to do is get a dump of the decrypted data when we're doing a bad run, and then one when we're doing a good run. So what do I want to do here? I want probably a new tab, and let's go to GBA folder in here. It's very hard using a non-Mac keyboard on a Mac. So what do we want to do? What do we want to do? In fact, first of all, I'm going to start by calling pkmnfr.sav copy 3. I'm going to call this something much more sensible, like base.sav. So if I copy base to PokemonFR.sav, this is going to make our program use the bad version. So this is going to output the bad data. Okay, luckily for us as well, encrypt, decrypt inner data doesn't do it in place necessarily. So we can see what the decrypted data is by the time we get here. So let's do the same nickname as before as well. And then, okay, so decrypted. Now I need to figure out a way of copying these. Can I just copy straight to clipboard? Is that going to work? So this is bad. Okay, that kind of worked, but not really. Oh, why did it copy that printout as well? I don't want this. Can I not just, like, straight up take the bytes that I want? Customize... Copy value. Is that going to give me a better result? What does copy value do here? Nothing? Copy value. Okay, that doesn't actually let me copy anything. Wait, actually, what do I really want to do here? Because decrypted is straight up our decrypted data. What do I want to do? What do I actually want to do here? Do I want to compare the structured decrypted data? Not really. I want to see what... yeah, okay. The problem is... I want to see, really, this is most useful in the context of the save file. I mean, it might be worth comparing both. It might be worth comparing both. I guess then, what if we loaded... So this is our bad copy. This is our bad copy right here. How am I going to get these bytes out, though? Do I need to literally, like... write a new file? I suppose I'm probably gonna have to do that. Let's call this bad snapshot. And what do we want to do? We want to write decrypted based on the size of decrypted. Is that not gonna work? Oh, size of a dereferenced decrypted object. One time. And then that's our file. Although I don't think we can call this dump anymore. This has to be... Oh, wait. Shit. Okay, I probably can't do that safely. Let's call this snap. What do I want to do then? I probably can't do that either. So let's call this snap FW. Really, this should be a function. But yeah, whatever. Okay, so this is going to save the bad set of bytes when we do this again, so we know exactly what we're looking at. And there's a reason I'm doing this. There's a reason I'm doing this. So we want to run this program again based on the bad data. So let's set this to high. Brilliant. That's saved. We should have a file now called bad snapshot, which we do. And when we run the game after moving dump, it should fail. So we want to make sure that we've just exported a bunch of bad data. So this should be the bad version. Yes. Let me just see how we're doing for time. Got about 10 minutes. So Yes, this is the bad snapshot. So what we can actually do here is open it in the hex editor and export these bytes, but that's wrong. That's not decrypted. What? Is it the decrypted data? No. Yeah. No? Why is the decryption key literally in there? I don't think this is right. I don't think this is right. I don't recognize any of this. What? Did I write the wrong... Did I write the wrong data? Maybe this is not right. I don't know. Let me see what we're actually doing here. So, decrypted should not look like what we saw here. Yeah, so where is this like 30 coming from? Because it should be 0700 OD. F-right takes a pointer. Isn't decrypted a pointer already? Yes, okay. That explains it. So I had a typo. Love that. Right, let's try this again then. So if I do hi, we now have bad snapshot again, but this should look more sensible. Yes. So what I can do is export this into C bytes, however we did it. I think we just did that, and export as code. And this time we want to do it in C so that we can compare in there, in the code. So I don't want to do this anymore, but what I do want to do is paste this in, and now we have a UC data block. And then what we probably want is to cast this to a Pokemon data type. So yeah, so Pokemon data type block is a Pokemon data type UC data block. Oh, what is the issue? Cannot cast from unsigned car via C-Star cast. Is it because we need to do it by address? Okay, I think that's it. Cool. Okay, fine. This needs to be called bad. Let's call this bad block, actually. So this is going to give us, in the memory view, if I do this right, I need my breakpoint to be here. So we're going to have bad block, which is the data that we snapshotted a minute ago. But actually, after we move dump back, it will now work. And so decrypted will be good, and bad block will be bad, and we can see what the difference is. So let's do the same nickname. Where am I looking? Okay, so bad block has growth, or species 7, held item D, XP, friendship, unused. Although maybe there's something that should be very obvious here that jumps out anyway. But there's actually nothing in the bad data block. So what the heck is going on? What's the difference between that and decrypted? Wait a minute, decrypted in this context is the encrypted data? It is. Okay. Wait, is that right? Because I don't recognize any of that. We should be looking at 8F, CF, whatever. It should not be whatever this is, I don't think. Oh, wait, no, sorry. It is, but decrypted is... Oh, the order doesn't match. Decrypted right now, what we're about to write back at this point, or I guess what we have written back? No, sorry, I need to be looking at... No, I can't be looking at Squirtle's data because we've encrypted it. Decrypted right now is... No, sorry, the order is different. So this, when we do the bad block, starts with 07, OD, what have you. So I don't think any of our actual like calculations are wrong. It's just the control. Somewhere we are but trying to write according to how we've structured the type that we defined. So because we have all of these different flavors of... Let me actually open this in a new tab. So because we have all of these different flavors here, we want to load these into a fixed structure. So any Pokemon can have the data in a different order. So the first 12 bytes could be these, or the first 12 bytes could be these moves, or miscellaneous, whatever. Because that happens, to modify the dates, to make us best placed to modify the data, I've got a fixed type called Pokemon data type, which is literally a fixed order. And I have functions that write to... yeah, okay. I have functions that write to this structure when loading the data. I guess that's init data does that. Yeah. So I'm saying initialize a Pokemon data type, like our static type, and based on the Pokemon you pass in, it will fill that memory based on this order. So if we have GAEM, it will do GAEM. Or it will assign in the correct place. So the first 12 bytes are G. Yeah, the second 12 bytes are A, and so on. So somewhere what we're doing is in the bad variant, we're trying to write back to... So Squirtle's order, we discovered ages ago, is EAMG. However, we are writing the data back in the wrong order. So whilst our checksum... So our checksum is still going to be correct. That's why it's not a bad egg. But the order of the data is wrong. Okay, that makes sense. That makes sense. I think, anyway, this is what's going on. We won't know until we can prove it. So, fine. Encrypt, decrypt inner data is agnostic to type. So where do we use this? We use it twice. First of all is when we decrypt the encrypted data from the save file. The second time is 19 something or other. Yeah, here. Where we take decrypted and... Oh, and we write it back to Squirtle's data. No, that can't be. Well, then why is it messing up the order? Why is it messing up the order? I think there's a few references to... Why does it not show the text preview? There we go. Okay. So we have a few references to Pokemon data substructure. The first one is when we just print the personality value mod 24, so that's fine. And then we use it in the init inner data, which is what loads our Pokemon data type. And then we use it again when we write the inner data. Okay. So really, this should be agnostic to how we're writing the data back, but I don't think it is. So it's taking whatever Pokemon data type we have in here and writing based on... So when does that... So this works when the decrypted data has a completely mangled order. So decrypted in this case is this Pokemon data type we pass in here. Is that right? It is... Right, actually I don't know that yet because... Wait a minute, where are we calling write in a date? Are we even using it? We must be. Oh, we're not. Hang on, how are we setting this data back then? What? Oh, because we realized we didn't need this function. But I think we do. Yeah, I think we do. I don't think we can straight up just write back to Squirtle's data. Interesting, interesting, interesting. Okay, so what we need here then is a new buffer. Let's just call this buff and initialize it to nothing. And this needs to be our buffer. So this is going to give us the data like encrypted, ready to write back. And then I think I need to call pkmn. Hang on, I'm in the middle of something. Alarm. Then I need to call write inner data. Yep, so Squirtle is my Pokemon, which Squirtle is a pointer. Yep, and then I have my buffer, which is what I want to write. Yeah, okay, so decrypted at this point is in the mangled order, and that's what I'm expecting. That's what I want. So even though decrypted at this point will still be in the correct order, we know that by calling this function, we are setting that data back the correct way because we're EAMG, wherever that is in this set of enums. I think that should work. Okay, so before I forget, I'm actually going to do a to-do here. Is language getting mangled? Let me actually do writing too many bytes from nickname. Yeah, let's try this again straight up using our original file. So cp base to Pokemon FR. Now that we've added that call to write inner data back in, Yeah, this should be fine now, hopefully. Let's do hi. Move dump.sav back to Pokemon FR, and then let's load in here and see what we get. Yes! Okay. Okay, woo! I cannot believe something as simple as that took me an hour to debug, but there we go. Okay. Perfect. Fine. When I write functions in future, I should probably use them. I'm just very glad that worked. So, what I will probably do off stream is fix this up, push a couple of commits to GitHub, and also what I desperately need to do is get rid of all of these save files, because we've just started the game, so I actually don't really care if I lose any of these, because we already know that we can now reliably modify data. So that's it. Thank you for your patience there. I'm glad we were able to solve that problem. Really, because we've just been trying to do one objective after the other, a lot of this data needs, or a lot of this code desperately needs cleaning up. So I will do that eventually. But yeah, I think probably can stop there. Thanks again. I will see you in the next one. Bye-bye.